heartily welcome you to today's physics class. Today we will discuss chapter sound, and under that we will discuss free vibration. So now let us have the concept of free vibration. Vibration and natural vibration are same. So first of all, let us imagine a situation where I have taken a simple pendulum, hanging this simple pendulum, and I want to disturb it from its mean position. So what I will do, I will lift it this side little. So when I am lifting it from this position, little this side, it is lifted, and I leave this. So it will start oscillating. So from mean position, it will go to this position. Again from this position, it will come to that another extreme position. Again to the mean, another extreme position. It will oscillate. So now let us take a situation. Let us have, as usual, condition, air condition. Let us take. So in air condition, when we are taking such vibration, in that vibration, this vibration occurs from mean position, goes to the extreme, again comes another extreme, again it will be, so it will move like this, and at a sub time it will stop oscillating. Okay, so what happens in this case? There is something external forces acting on the body, that is why there is a change in that amplitude. This one, it is amplitude. So there is a change in amplitude and the body comes to rest position. Now imagine such a case where there is no external forces acting on the body. Means nothing external, no friction, nothing is acting on the body. So in that say, this condition will be a vacuum. Okay, so this condition will be a vacuum condition. So let me take this oscillating pendulum here. Let me take this one. It is the first of all, which one I had discussed. So this one, it will be from this position, again, it will be come to rest. Okay, so now this is the position, this is in the air. Let me take another situation. Let it be vacuum, where there is no external forces acting, and I am hanging one pendulum, and this pendulum is shifted from one position to another position. Little I disturb from this position to this position, let it be. Then I leave it. So again it will come to this position, another extreme. Like this oscillation will continue. Yes or no? Continue. And here one thing we will see, there will be no change in its amplitude. But this case you see, amplitude goes on decreasing. Here first of all, this one is maximum. Now it is less. So amplitude goes on decreasing in case of air, because resistive force is acting on that body. And here the resistive force is, let it be the frictional force of air. But as I have taken another medium where vacuum, there is no external forces acting on the body. In that case, the body vibrates in its own frequency and own amplitude. Okay, so this vibration where there is no external force, vacuum, no external force is acting on the body, amplitude remain constant, and such type of vibration is known as free vibration, and other name of free vibration is natural vibration, and it is periodic also, because whatever time is taken from here, it is coming the same, exactly it is repeated after the same time. That is why it is the word periodic. Okay, and here the vibration known as natural vibration, the frequency at which the body vibrates, that is known as natural frequency. Now let us see what is the definition of natural vibration or free vibration. So a periodic vibration of a body in the absence of any periodic force on it is called natural or free vibration. Otherwise we can say, right, the vibrations produced in a body being slightly disturbed from its mean position are called free or natural vibration. So when we are discussing free vibration, this absence of any periodic force is very important. Absence of any periodic force means that one will be body should be at vacuum, then only it can be possible. And here written, the vibration produced in a body being slightly disturbed from its mean position are called free vibration. If I am taking here, if I am taking a body, pendulum, here it is vibration produced being slightly disturbed. I have taken this body to one side. Here let it be taken this one body to one side and leave it. After that one, it will start oscillating in the absence of any force. So no forces, external forces acting on the body. So this is known as free vibration or natural vibration. Then the word comes, what is natural frequency? So natural frequency here, natural frequency. So natural frequency, usually it is represented by n, small n, and here this natural frequency, it is frequency of a body which vibrates in its natural vibration. Okay, and here you can write that one, the number of vibration executed per second by a free vibration. So frequency of a free vibration is known as natural frequency. And what is the natural time period? What is the natural time period? Here, the time period in which the body oscillates is known as natural time period of the body. And the most important thing which I am going to explain you is this natural frequency of the body. This one is important. Natural frequency of the body depends on, because question comes, okay, on what factors does the natural frequency of a body depends? So natural frequency of a body depends on its intrinsic properties. Means what is that intrinsic properties? These properties are depends on intrinsic properties like shape of the body, size of the body, and elasticity of the body. So this one is important. So natural frequency of the body depends on shape, size, and elasticity of the body. Now let us see that some examples of natural vibration. Okay, so as we have taken the simple pendulum example, so here let us take this same simple pendulum. Here I have taken simple pendulum. Obviously it is oscillated, and here while discussing this simple pendulum, it is in vacuum. Remember, vacuum, which practically is not possible for us, but as we have to take no external forces acting on the body, that is why we are considering the system as a vacuum system. Okay, where no external forces acting on it. So here one thing remember, you go to Newton's first law of motion. What does it tell? First law of motion tells that one, when no force is acting, no force is acting on the body will continue its inertia. Body will continue its inertia, means if it is at rest, it will remain at rest, and if it is in uniform motion, so it will be in its uniform motion. So here the same thing we can apply here. No external force is acting on the body, so the body will oscillate in its natural frequency. So there will be no stop here, and here whatever amplitude I have taken, this amplitude will remain constant forever. Until unless body is at vacuum, this one will be oscillating. Understood here? So, if I will take this one, it is the length equal to L. Obviously, acceleration due to gravity, Z will be there for us. So, what it can be? The frequency of a simple pendulum here. So, frequency of a simple pendulum, F equal to 1 by 2L root over Z by L, because we know that formula for time period equal to T equal to 2 pi root over L by G, but time period equal to 1 by frequency. So here that is why frequency it is reverse. So frequency equal to 1 by 2 pi root over G by L. So if this length of a body remains constant, then this frequency of a body also will remain constant, because acceleration gravity is constant always, because at the same place we are considering, no, that is why. So remember this one, this is this example, and this frequency of a free vibration of a body, and remember it is in vacuum and in case of vacuum only. So what I told here, this is a body where amplitude remain constant, because no external force is acting on the body. Here the body is executing with the same amplitude every time. Remember this statement. This statement is very important for us. If this one is a, this one will be a, till it for means all the time period it will be same only. Now let me go for a graph. Here let me take a graph. Here this one will be time period, this one will be displacement of a body. Every time this displacement remains same, so amplitude remains same. If amplitude remains same, so both the cases amplitude will be here only. So let me take this one like this. Why I am considering? Because amplitude have to remain constant. That is why the same thing for I am counting this. Okay, so here all this will be the transverse wave. Okay, so this one will be transverse wave, where this amplitude will remain constant. This amplitude remain constant. Okay, so this one will be vibration occur in, or free vibration. This is the graph for free vibration or natural vibration of a body. Or usually question it comes, if a simple pendulum, question can be, if a simple pendulum or a body, simple pendulum, it will be easy for us to explain, that is why we are taking this. If a simple pendulum is oscillating in vacuum, draw the displacement time graph for its vibration or oscillation. Okay, so answer will be this one. This is a free vibration, where mention this one as a. If we will mention, then it is understood that it will be the same thing, means same amplitude it is continuing. Now we are considering the vibrations produced in a stress string. Here, whenever we are considering vibrations in a stress string, indirectly we are going for the frequency produced in the stress string. Okay, so stress string means we are taking a string, and both let it be the string I am taking, and the one side of the string it is tightly held, or both the sides can be tightly held. So whatever, if we are plucking this one at some end, if it is string is plucked, here it can be plucked. Okay, so it can be the vibration produced, or vibration can be produced like this, it can be vibration. So different type of vibrations can be produced in this case. Okay, so here this vibration produced, because we are considering here all these are the free vibrations, here we consider for the free vibrations. Okay, remember this one, till now we are going for the free vibration or natural vibration, where the vibration or frequency remain constant, it cannot be changed. So that vibration or that frequency depends on what are the factors on which this frequency of the stress string depend on. So the important this and this one, it is most important thing for us, because question usually comes for this one, board question also comes. After discussing, I will tell you this one. So frequency produced here 1. This is also known as law of length. Also it can be directly, we can go for it. So this frequency, it is inversely proportional to the length of the string. It is frequency, it is inversely proportional to the length. Okay. Second one. So here one thing also we can write down for here is F1 by F2 is equal to L2 by L1, because question comes for this. That is why all these are important. Have to remember. Frequency increases when length of the string decreases. That is why if you want to increase the, if you want to increase the frequency of stress string, then bit 1, here it is want to increase. So here what can be? Decreasing the length of the stress string, because here decreasing the length of the stress string, it is because it is inversely proportional. So one thing you remember here. Next, what we will discuss? Second thing, it depends on the mass of the string. It depends upon the mass. So otherwise this is known as here law of mass. So one thing, tell me, if we are going for the frequency means number of oscillations per second. Yes? So what do you think? Mass will be more, then frequency or number of oscillations will be same, increase or decrease? Obviously mass will be more, means number of oscillations will be less, and number of oscillations is indirectly known as it is known as frequency. So law of mass tells that one, F is inversely proportional to mass of the body. Here when we consider the mass of the body, means it is the mass per unit length. Here we can write mass per unit length. One thing, remember this one. So this one is mass per unit length. Here also we can write this one for us. Like that we are telling mass, but really it is F is inversely proportional to the square root of the mass. Okay, so but here F inversely proportional to the mass of the body. So here if you want to increase the frequency of the stress string, what we can write next? Decrease the mass of the body. Yes, mass of the stress string. Understood or not? This is the thing I am writing. Third one, what I will go for third one? Third one will be the law of tension. Third one, the law of tension. Okay, when we are taking a string, that one will be for tension forces acting on the body. So here F is directly proportional to root over of tension T. Okay, tension of the string increases, frequency increases. So here to increase the frequency, third part what it can be? Increase the tension. Okay, so combiningly these three, what we are, so here also what it can be? F1 by F2 is equal to root over T1 by T2. Okay, this one is the law of tension. So here what we can write? Combiningly all these things. So here what we got now? we got F inversely proportional to L, F inversely proportional to the mass, square root of the mass, F directly proportional to the tension. So combiningly what we are getting? Proportional to here root over T by M, here L. So after calculation what we are getting? This one equal to F equal to, so F equal to 1 by 2L root over T by M. From this equation, this one can be understood. If it is question, this is board question. Here, if it is asked, how, if you want to decrease the frequency, what you will write? Increasing the length, decreasing the tension because directly proportional, and increasing the mass of the body. Okay, so this one combiningly we are getting this, and we will solve the numerical, but let us finish this. After that one we will go for it. Okay, so now another interesting thing we are getting, this one it is, we got F equal to 1 by 2L root over T by M. Here if I consider this one mass of the body, so here also I can represent this one, this depends on density of the body. So here we can write F equal to T by M, M equal to mass. So here density equal to mass by volume. According to this one we can write here volume equal to the formula we can put, and here we can write 1 by 2L root over T by pi r square d, where r equal to radius of the above. So here depending upon radius it can be thick or thin. Okay, so it can be thick or thin, and this one equal to d stands for density. So obviously more density, less will be the frequency, less will be density, more will be the frequency. So here what it depends on? Here previously we knew frequency depends upon the length, depends upon the tension, depend upon the mass. When we are discussing mass, indirectly we are discussing about the radius or thickness of the substance and density of this substance. Okay, so all these factors have to remember, because we have to solve some numerical, or this part is most important, because board question comes like this. Now let us take a string of a fixed length. I have taken, this is the length of a fixed length. This one it is the length I have taken, and this is the two ends of the string, and this two end of the string, it is fixed. Okay, so this is a fixed, and here what we are going to do, it is length L I have taken. So from the middle, let it be from the middle, I want to disturb this one. I will just pull it some down and I will leave it. Remember, we are discussing free vibration or natural vibration. Okay, so where frequency remain constant. So here it is the length, particular length I have taken, and this particular length I have plugged in the middle. When I started plugging in the middle, it will start vibrating. When it will start vibrating, it will look like this. Yes, it will look like this. So when it is looking like this, this is the maximum amplitude, this is the minimum amplitude. This position is known as node. This position it is known as antinode. This one it is node, and this one it is antinode. And node is the position. Node is the position where tension is maximum, and displacement is minimum. Antinode, this is in the middle. Antinode, tension is minimum, displacement is maximum. Antinode and displacement is maximum. Okay, so now let us go for this frequency of this body. Okay, so here I have taken this one L. So F equal to 1 by 2L root over T by M. Yes, understood. Now this is the first diagram. Let me go for the second diagram where this is the same length I have taken. Same length taken. Here both the sides, all these are fixed. Okay, this is the middle, but instead of plucking at the L by 2 position, now I will pluck at the L by 4 position. So when I pluck from the L by 4 position, I will get the vibration will be like this. Vibration will look like this. Okay, so here previously I have taken, this is the entire length, this is also entire length, but now I am getting two vibrations. So each length will be L by 2, L by 2. Yes or no? This one will be L by 2, L by 2. Now what will be the frequency? Now this one let it be F1. F1 equal to 1 by 2L. So here let me calculate this one. Here F1 equal to 1 by 2L root over T by M. So here L, in place of L I can put L by 2 root over T by M. Okay, understood this one. So I will not cut this 2. Let me keep 2 by 2L root over T by M. So now for me this one 2 by now this one 2 by 2L root over T by M. Now this one will be F or not? Yes. So what I can write here? I can write this one equal to 2F. Can I write it like this? Because here F1 is the frequency for this stress string where we are getting two loops. So frequency equal to 2F. Got it? Now let us see that one. Another for us where I will take this vibration. Another part let me take here. This same thing I will take to fixed position. Here I have taken, instead of plucking at that L by 4 position, let me pluck from this L by 6th position. So here L by 6th position. So here if it is L by 6th position, this loop will look like this. This one will be L by 3 length, this one will be L by 3 length, and this one will be L by 3 length. Understood? This one is the third diagram. So here for F2 I have taken F1, this one this one, F1 this one. Now this one will be F2 position. So F2 equal to 1 by 2L root over T by M is equal to 1 by 2 L by 3. Because why L by 3 taken? Because each loop length equal to L by 3. Here each one having this length L by 2. That is why it is taken like this. So what I am getting? 3 2L root over T by M. So equal to 3F1. Sorry, 3F. Got it? Because this one, it is your F. So what I am getting here? Here frequency, whatever there, here it is 2 times, and here this one equal to 3 times. This is known as principal node. Here this one it is principal node. This one it is first subsidiary. This one equal to second subsidiary. Okay, so like this, and here the frequencies are in the ratio 1:2:3:4. It continues. The frequencies are 1:2:3, like this. It continues. Okay, so this one it is for a stress string. Okay, this one it is important question, and I hope you understand this one. And in any sort of confusion, please ask me in the comment box so that I can be able to clear your doubts. Okay. Now we have a question. A wire of length 80 centimeter has a frequency of 256 Hz. Calculate the length of a similar wire under similar tension which will have frequency 1024 Hz. So here what to put? We know the formula here because your length is given. So we will go for law of length. Law of length tells that one F1 by F2 equal to L2 by L1. Yes, but what is the data given to us? Wire of length L1 equal to 80 centimeter has a frequency. So F1 256 Hz for us. Yes, calculate the length L2 equal to how much? And here F2 equal to 1024 Hz. This is the data given to us. So let us put the value. So L2 equal to F1 L1 by F2. Yes, for us. So what is F1? 256. What is L1? 80 centimeter. Here F2 1024. So I think 1024 equal to 4. 4 4 24 4 20 22 8. Okay, so now this one equal to 20. So this answer will be 20 centimeter. Okay, so L2, length of L2 equal to 20 centimeter for us. So like this question comes in the board, and this one it is a similar question has come 2 years back, 17. It is a board question. Now we'll see frequency produced due to the air column. So when the word air column comes, simplest example let us take. Here let it be a bucket is there. Okay, and from the tap of water comes inside. So first of all it was the length, it was the water level. So for us this is the last one. So this one will be the air column for us, length of this air column. As length of this water level increases, this is the air column decreases. Okay, so as we go up here in the bucket of water, air column decreases. Here what we are considering, this is the length of this air column. The best example let us take when we are considering a fluid. Okay, so now let us take this, let it be the diagram of fluid. I am not perfect in drawing, but let us have the concept of fluid. Both the ends are open. Here there will be some holes. Here there will be some holes. Here there will be some holes. When this fluid player, it plays or blow air. Air is blown inside. So he keeps the finger on this one, on this one, on this one, depending one close, another leaves like this way. So when he closes, he changes the air column. So as we know previously, frequency whatever it may be, frequency will be depend on 1 by 2L root over T by M. So here the word L or the length is important for us. Here by changing the length of this air column, the frequency changes. So here keeping in our mind, let us go for closed organ pipe and open organ pipe. Let me give you two examples here, just for your clearance only I am giving. So open organ pipe. Okay, here it is closed organ pipe. We will not go detail, only we will see that one. Open organ pipe. In case of open organ pipe, both the ends are open. In closed organ pipe, this lower, this one will be, one end will be open and next other end will be closed. Okay, when this nodes, antinodes, we got that one, it is produced, it will be like this. Okay, but here what it will be? It will be just like this. Here antinode, node, antinode, node, antinode. Here node, antinode, node, antinode will be formed. And here important thing for us just to know that what is the ratio of the frequency, because in case of stress string we have seen stressed string, the frequency ratio is 1:2:3, it goes like that. So what will be the frequency ratio in open organ pipe and closed organ pipe? Okay, so now let us see. In case of open organ pipe, this one will be in the ratio, this one will, open organ pipe, this ratio will be 1:2:3, it goes like this. But in case of closed organ pipe, this ratio will be 1:3:5, even multiples, it will be like this. Only just to remember, +2, you will go detail for it. Okay, so this one will be like this. Other examples can be taking the tuning for, we are striking that one, the hard rubber pad, the vibration it is produced, that is the natural vibration, natural frequency. And one thing remember, everybody, whatever body that exists, whatever substances they exist, if those are, we are striking and made it to vibrate, they vibrate first of all in their own natural frequency, or that is the natural vibration. And that natural frequency of a body differs from body to body, shape to shape, and depends upon the elasticity of the body. This is the main concept of this natural frequency. And remember that one, while we are discussing natural or free vibration of the body, no force is acting on the body. Okay.